Hi everybody, Miss Miseracco here. We're going to solve some half-life problems together. So in the first problem, I'm going to just read it to you. It says, if the half-life of iridium-182, that is simply our isotope we're using, is 15 minutes, how much of 1 gram is left after 45 minutes? You'll notice as I'm reading the problem, I am kind of highlighting the information, kind of pulling out the key points. So the way I like to solve this problem, and you maybe know a different way, but I find this way very easy to remember, is by using a T-chart. So I make my T-chart, and on the left-hand side of the T, I'm going to label time. And on the right-hand side, I'm going to label mass. My time always starts at 0, and then I'm going to look back at the problem and see what exactly I'm trying to figure out. So here it tells me for my isotope, the half-life is 15 minutes. I start with a 1 gram sample, and I want to know how much is left after 45 minutes. So my starting mass at time 0 is 1 gram. To the time side, I'm always going to be adding my half-life. To the mass side, I'm always going to be dividing by 2 because half of it will disappear. So I add my first half-life. 15 minutes have gone by, and now I have half of a gram of the parent isotope. Another 15 minutes go by for a total of 30 minutes. Again, I'm adding on this side. I divide 0.5 by 2 and I get 0.25. So 25 hundredths of a gram remains. I add another half-life for a total of 45 and I get 0.0125 on this side. So going back to my question, it says if the half-life of iridium-182 is 15 minutes, how much of a 1 gram sample is left after 45 minutes? My answer is going to be 0.0125 grams. And so I always like to write my answer somewhere and make it visible for whoever's looking at my work. So that's the first one. You may want to pause this video and copy this down into your digital notebook. Question 2 says a 208 gram sample of sodium 24, again, that's just my isotope, decays to 13 grams within 60 hours. This one is a little bit more complex. And we're trying to figure out what's the half-life. So I don't know what the half-life is here. So again, I'm going to start with my T-chart. Time goes on the left. We always start at time 0, and our mass goes on the right. I start with 208 grams, and it's going to go down to 13. So I've got 208, then I have 104, then I have 52, then I have 26, and then I have 13. And that is the number that is mentioned in the problem there. So I know I need to stop. At 13, it's taken 60 hours. So now I see 1, 2, 3, 4 have elapsed. So 60 divided by 4 is 15. So let's see if that works. If I add 15 here, another 15 would be 30. Another 15 would be 45. So it does seem to work. So I counted the number of half-lives. Again, it was 1, 2, 3, 4 have gone by. I divided that time to find out the number is 15. So again, if I'm trying to answer my question, what is the half-life of this isotope? The answer is 15, and my units are hours. Again, please pause this video and copy this work down into your digital notebook. And then there are 3 additional problems for you to try, as well as an assignment on Canvas. Thanks for watching. If you have any questions, please email.